Hi, we're going to do lesson 12, six tangent segments in intersecting chords. Okay, so theorem 66 says a tangent segment to a circle from an external point are equal. Okay, so I always call this like the party hat theorem because if you use your imagination, like if there's a face here, this is a little hat, like you wore to little kids' parties when you were little, and so all it's saying is these two segments, and they are tangent segments because they touch at one spot, they're equal in measure. So these two are equal. So that's just a 13. Okay. So if you ever hear me talk about party hat theorem, this is what I'm talking about. Okay. So, intersecting chord theorem. Now, this is interesting how this works. And I really don't understand how it works, but it works and it's really awesome. So it's called the intersecting chord theorem. So if two chords intersect inside of a circle, the product of the lengths of the segments of the first chord is equal to the product of the lengths of the segments of the other chord. And so we're going to take these two lengths here. It doesn't matter which one you start with. So 5 times 8, and this equals the product, which means multiply these two, which is 4 times x. So 40 equals 4x. Divide, and x is 10. It's pretty awesome. All right. So, it's all just practice problems. Okay. So you just have to know how to use the theorems. So the first one is what we just practiced. Okay. So 9 times x equals 6 times 15. Let's grab a calculator. 9 times 15. I'm sorry, that's 6 times 15 is 90. Oh, the answer is 10 again. Okay, coincidence. Now, usually I kind of fool people at first on this one, but it's actually a bunch of party hats. There's four. Okay, so that means these two are the same, so that's a 6. And these two are the same, so that's a 5. And these two are the same, so that's 2. Obviously, not the scale. And these two are the same, so that's 3. So we're just going to add it all up. Okay, so this side's 11, this side is 7, this side is 9, and this side is 5. So 5, 7, 9, and 11. The perimeter is 32 units. It's that easy. Yeah. Okay, so we have 2 here. This is another party hat problem. Now, sometimes the party hat problems get more difficult. Well, I'll show you. This one looks pretty basic. Like these two are 8, these two are 3, these are 17, and these are 7. Okay, so let's add these up. Um, 3, 3, 17, and 17, 7 and 7, 8, 8. So that is 70 millimeters. Okay, now this one's a little bit more complicated. So if you want to pause it and try it, go for it. I'm going to have to start up here where this is 15 and then take 24 minus 15. So 24 minus 15 is 9. And that means these two are the same, so that's 9. So 21 minus 9 is 12. And then these two are the same, so that's 12. So it doesn't really tell you what your actually it's just find the perimeter. So never mind, it tells us. And this entire length is going to be 27. So we have 21, 24, and 27, which is 72 feet. Okay, so these are practice problems from the chapter, and when the video ends, I'll just make a part 2. All right, so these, again, it's about the vertex. The vertex is on the outside, so you're going to subtract these two. Now, this one looks weird, okay? Technically, this goes like this. So there are two distinct arcs. So 130 minus